Hello everyone, welcome back to our channel Problematical. Today we'll continue our discussion on Chapter 2 Polynomials from Class 9 Maths NCERT. Today we'll discuss about division. So let's divide two numbers first. Let's divide 15 by 6. 15 will be written over here. If you're dividing 15 by 6, 6 outside, we know that 6 2s are 12. This is equals to 3. 3 is your remainder. If you divide 12 by 6, you will get 0 as your remainder. In the first case, 15 is said to be a dividend. 6 is your divisor. 2 is your quotient. And 3 is your remainder. In the second case, 12 is your dividend. 6 is your divisor. 2 is your quotient. And 0 is your remainder. Now we have considered numbers, division of numbers, also called as division of constant polynomials, or division of non-zero constant polynomials to be precise. We can also consider division of polynomials. So in polynomials, your dividend is represented by p of x, divisor by g of x, quotient obtained by q of x, and remainder left behind by r of x. In these two practical conditions, here we have a non-zero remainder, and here in the second scenario we have a zero remainder. So if your remainder is 0, then 6 and 2 are called factors of 12. 6 and 2 are factors of 12. Similarly, we can also say that 12 is the multiple of 6 and 2. Twelve can be written as 6 multiplied by 2 plus 0. Here, similarly, 15 can be written as 6 multiplied by 2 plus 3. That means your p of x will always be equal to g of x multiplied by q of x plus r of x. In the second scenario, we can see that 6 and 12 are not factors of 12 just because your remainder is non-zero. With this discussion, let us divide some polynomials now. Before division, let us summarize this in the form of a theory. So we have obtained your p of x is equals to g of x into q of x plus r of x. That is, your dividend is equals to divisor into quotient plus remainder. Now, when r of x, your remainder, is equals to 0, then g of x and q of x are factors of p of x, and p of x is the multiple of g of x and q of x. your R of x, if you observe in the previous slide, your R of x value takes either 0 value or a value which is less than this divisor. 3 is less than 6, 0 is less than 6. So your R of x is equals to 0, or in any situation, your R of x will always be less than your G of x. That means your remainder is less than your divisor. Now this is when you're considering numbers, or this is when you're considering constant polynomial. What happens if you're considering other type of polynomials? In other type of polynomials, your degree of R of x will be less than your degree of G of x, or your R of x will be equals to 0. For polynomials other than constant polynomials, zero polynomial is included over here in constant polynomials. Now let's actually try and divide two numbers. Divide two polynomials. Let us consider p of x as 2x cubed plus x squared plus x, and g of x as x. We are supposed to calculate q of x and r of x. P of x will be written inside 2x cubed plus x squared plus x, and g of x outside. The very first thing you'll do is take a rough part, make a rough section in your copy, because initially you will require this rough section to calculate things properly. First, you'll take the very first term of your p of x and you'll divide it by the very first term of your g of x and get a value. Whatever value you get, you will then write it in the place of q of x, which is 2x squared. Now, you'll take the same value and divide and multiply it by g of x. Now here you have only a single term of g of x. That means your g of x is a monomial, but you might have g of x as binomial or trinomials, as we'll see in further examples. So if it is a binomial, this 2 of x will be divided by the complete of g of x. Not just x, but whatever else terms we have in g of x. So here you have to multiply this 2x squared by g of x, 2x squared into x, and place it at the second level, 2x cubed. Now you'll subtract 2x cubed minus 2x cubed. What this subtraction did is changed the signs of the second level. The first level is given, second level is, this subtraction will change the sign, and this value will be equal to 0. Now you'll take down whatever else terms are left with p of x. Next step, take the very first term of px squared, v of x, and divide it by the very first term of g of x. X. Place this x over here. Now the sign of x is positive, hence you'll place a positive. Next step, multiply this by g of x. X into x is x squared. Subtract, change the sign of the second term. X squared minus x squared is 0. Take x over here, left of p of x term. Divide this x by x, you'll get 1. So plus 1. Multiply this 1 by x, you'll get x. Subtraction, your answer is 0. This is your remainder, and this is your q of x. So your q of x is 2x squared plus x plus 1, and your r of x is 0. So if your r of x is 0, we can say that x and this complete 2x squared plus x plus 1, these both are factors of this polynomial, and or p of x is the multiple of these two terms. So with this we can say that x and 2x squared plus x plus 1 are factors of 2x cubed plus x squared plus x. Let's consider another example where p of x is the same 2x cubed plus x squared plus x, but your g of x now is a binomial, say x plus 1. Again, you are supposed to calculate q of x and r of x. You'll write them in the standard form, which is 2x squared plus x squared plus x over here. G of x over here, and chalk up your rough part. Now in the rough part, you take the first term, which is 2x squared, and divide it by the first term of g of x, which is x. This x gets cancelled with one of the x and you're left with 2x. Whatever value you have, place it over here. 2x in place of q of x. Now take the term that you just placed and multiply it by the complete g of x. 2x squared plus 2x. This is what you get. Next step is write this over here. Now x squared term will be written underneath x squared term, 2x underneath x term. I think I made a mistake over here. Yeah, it is supposed to be cube. Sorry. So it is 2x cubed plus x squared plus 1. First term, 2x cubed divided by x, and you will be left with 2x squared. This is 2x squared here. 2x squared has to be multiplied by the complete of g of x. So you'll get 2x cubed plus 2x squared. Subtracting 2x cubed plus 2x squared. So x squared underneath x squared, x cubed term underneath x cubed. Now subtraction means the sign of the second terms will be changed. 2x cubed has a positive sign, changed to negative. 2x squared has a positive sign, changed to negative. These two terms will get cancelled. 2x cubed minus 2x cubed. X squared minus 2x squared will leave you minus x squared. We'll copy down plus x as it is, part of p of x, not partaking in the solving part just yet. Now take the first term of p of x as it is in your rough part, minus x squared, and divide it with the first term of g of x, which is x. This will give you minus x. Write this term as it is over here, minus x. Next, you'll multiply minus x with x plus 1. Minus x squared, minus x. Write these as it is here. Minus x squared, minus x. Subtract, change signs at the second level. X minus x squared plus x squared will be cancelled. Plus x is plus 2x. Now observe, the degree of r of x is 1 and the degree of g of x is 1. They both are equal. Your degree of r of x should be less than the degree of g of x, which means you can further divide this. So you'll take 2x as it is, divided by the first term, and you're getting a constant 2. So plus 2, multiplying this with this, 2 into x is 2x, 2 into 1 is plus 2. Subtracting, change the sign of both, cancel, and you're left with minus 2 as the remainder. We'll write these values over here. Q of x obtained is 2x squared minus x plus 2, and R of x is minus 2. Since your remainder is not equals to 0, therefore, your g of x and p of x, the given value g of x, x plus 1, and the obtained value of q of x, 2x squared minus x plus 2, these both are not the factors of the given p of x, 2x cubed plus x squared plus x. So, now there's another shortcut method to calculate the value of remainder without actually dividing the two values of p of x by g of x. Now this we'll study in the next class in the topic remainder theorem. Thank you.